This conference will
And
now be
majorly
recorded.
I'll use this as a whiteboard alternative. And so today being the first class, again, I already gave you a brief level of overview regarding the application areas of data science. Today it will be a slightly different perspective. It is a perspective where you actually acknowledge the whole system, what's going on, what are the inherent natures of the things that we will deal with, and then we will talk about how we can approach this domain of problems. So data science, what is it? Like what is the core aspect of data science? Data. Yeah. And so I'll just briefly touch upon what do you consider as data. Yeah. So what is data? Yeah, pretty straightforward things. I usually do not indulge in hard definitions, but this is something which will just help you get a overview of what are the things that we'll possibly be dealing with. So just use your chat window and in a very short way try to summarize what do you mean by data. And needless to tell, your interactivity will help your learning progress as well. Otherwise it can get monotonous and you can get bored easily. So keep it as interactive as possible. Whenever I ask for any answers, feel free to indulge. Okay, so Shavik and Maitri say say collection of information, pretty much accurate, I would say. Anything else? Yeah, Neil says facts and figures, and that's correct as well. So most of the things actually revolve around these two things only. You basically say data is basically some kind of collection of information. And wow, thanks Shavik for bringing that up. I just forgot to start the screen share. uh, Ishita says collection from which information can be derived. And yes, more or less, you have a reasonably good idea of what data is. Yeah. So let's just briefly acknowledge what is the possible things that you can consider under data. So you say collection of facts, information. Now, one important aspect of this thing is how do you represent data? Yeah. And when you say representing data, the first thing that comes to your mind, I hope, is numbers. Yeah. So using some kind of numerical representation, you try to quantify certain things. Yes, but that's not the only way data can be represented. There are other things like you simply merely might use a collection of words. For example, person A is a builder, person B is a sportsman. Now this also has some kind of information going on, but it's not numbers, it's simple words. And more or less all of your things can be summarized in these two ways. But now let's acknowledge the spectrum of data. And when I say spectrum, no, these two simple things do not do justice of what type of data we can possibly deal with. So now basically we will try to acknowledge what are the ways in which we can represent data. Yeah. So we will start with the first thing being hard numbers. So at level 1 I would like to say something like numerical representation. Yeah. And if you can take a quick set of examples, you are basically talking about something like, let's say, a person's age, his height, salary, and so on. At level 2 you have something like ratings or reviews. Yeah, often you give ratings on e-commerce portals. It's basically like on a scale of 0 to 5 how much ratings you want to give. Or let's say if you're giving some kind of feedback, you say how good the class was it good, was it excellent, what is average, and so on. Yeah, so ratings is level 2 of kind of information. The third aspect is where things start getting a little hazy. Yes, and we are basically talking about something categorical in nature. Yeah, and some very clear examples for this can be, let's say, profession. Yeah, as I gave example, person A is builder, person B is a banker, and so on. Then it can be the state you belong to. I belong to Gujarat. Somebody else belongs to Hyderabad, somewhere, I mean, Telangana, and so on. So there is no, common shared scale on which the values corresponding to profession can be, compared. Imagine this: two people with age, 20 and 25. You can say this guy is older than that. But when it comes to, some categorical levels, you simply cannot say banker is better than, builder. Yeah, so there is some kind of the dynamic change in the data that we need to acknowledge, and we will very soon talk about the complexities associated to that as well. And then you have more complex information or complex data. And when you talk about these things, I think this page, okay, let me keep it till this only. So when you say complex information, you are basically talking about much more comprehensive and elaborate descriptions of data, which is usually attributed to text. Yes, you have a long description of somebody, that comes under text. Then you have certain images. Yeah, image also has some kind of information in it, so it's still counts as data. And then a stream of images becomes videos. And finally you have audio as well. So let us acknowledge what is going on through this whole spectrum of data, the description or the way data is described. So the first thing that I want you to acknowledge is, when we use numbers, the information is pretty much precise. Yeah, or let's say unambiguous. Yeah, the moment we shift to ratings, there is a little level of uncertainty or unspecificness that kind of seeps in. Yeah, take an example for sake. Let's say I review a laptop and I rate it 4.5 stars, and one of my peers also likes it laptop, but he rates 4 stars. Now there is no concrete basis to actually justify each of these ratings. Another example is, let's say I like the movie very much, and my peer says I like the movie very much. Both of us have exactly same phrases of words, rated. Basically both of us say movie was good, but are you sure that he and me like the movie equally well? Certainly not. Yeah, so there is some kind of no, sorry, ambiguousness coming in the moment we shift away from numbers. Yeah, but talk about numbers. When you say my salary is xyz, you exactly know what you're talking about. When you say my height is 6 feet 2 inch, you exactly know where you stand. So the point to note down here is that there is some relative scale. They share a relative scale based on which no you can compare things and see where they stand. But on this side, there is no certainty. Basically, information may not be consistent. Yes. And as we go towards right side, basically categorical data and complex ways of representing information, things start getting more and more challenging for us. Now, there was still some kind of relative things that you can compare. For example, 2 stars is less than 3 stars. So there is some kind of order to it which helps you rank things, but not a precise way of ranking things. But the moment you shift to categorical and complex information, you can't even have that. Yeah. So technically there is no relative scale over here on basis of which you can do compare anything. Pretty much everything acts as an independent information. Yeah. So somebody is a doctor, somebody is an engineer, it's just an independent piece of information. There is no scope of comparing anything. Yeah. So now when you say data science, you are actually talking about a wide spectrum of possible things in which analysis can be done. It can be restricted to numeric things, it can be restricted to ratings, it can be so basically data analytics or data science is basically acknowledging or dealing with whole sort of data, pretty much everything. Yeah. So this seems a good breakpoint for 1 minute pause. If you have any questions, no, use the chat window. I'll get started in 1 minute. So Shavik is asking, comments or observations will fall under complex category of data. Yes, certainly, because you are allowing people to have a descriptive way of giving more information. Yeah. If you had asked them rate the things, did you like it or not, then it is something more on the ratings side. But the moment you allow them a text box where they can express their opinion, it comes under complex things. Okay, so is Garima is asking if supervised and unsupervised learning is also something that is dependent on complexity of data. Not exactly, Garima. So we will shortly talk about the difference between supervised and unsupervised. Yes, the your approaches will change based on the complexity of data. But having said that, it has nothing explicitly to do with supervised or unsupervised. Okay, then we will move ahead. So now, like the previous activity was an attempt to give a casual introduction to the spectrum of data. Now we will talk about a formal structure that is very popular in people, data science oriented people. Basically, they have segregated data into two specific things. We say data can be represented by two things. First being numerical, and second being categorical. Note that this is conveniently missing out the third very important aspect, the complex data representation. Yes, so this is more of the traditional data science, conventional data science, which usually dealt with just two type of data. And under numeric, you can further segregate things into two things. One is a continuous value. Yeah, something that can be plotted on a number line. Yeah, number line has its own set of rules. Basically, as you move right, the quantity keeps on increasing with a steady rate of growth, and as you move left, the quantity keeps on decreasing again with a steady rate of decrease. So there is a constant scale at which things are growing or reducing, and that's why this type of data is often termed as continuous data. Another aspect of numeric data is frequency counts. Yeah, oftentimes you say, how many people visited my website, how many people made a transaction on my website, those kind of things. Now here, again, there is some kind of number associated to it, but technically it's not right to say that it is a continuous value. Yeah, for starters, the first thing is it will be absolutely whole number every time. You cannot have fractions within it. And the moment we factor in this thing, lot of approaches have certain challenges, and we will see that in future. So basically numeric data, two kind of subcategorizations. On categorical data, again we have two things further. The first of them being ordinal data. Yeah, any data which has certain kind of order comes under ordinal data. For example, ratings, or let's say feedbacks. You say excellent, good, average, bad. Yeah, there are four distinct levels that have certain order. You for sure know excellent is better than good. How much better? It's a difficult question to answer. Yeah, you cannot say excellent is twice as good as average. There is no basis to justify that statement, and that is the reason it cannot be considered under continuous. It is something called ordinal. Yeah, and the final thing under category comes as nominal. It is represented by distinct levels, but you cannot have any comparison between them. Basically they are distinct pieces of information. For example, let's say the state you live in, the profession you work in, those kind of things. Now you cannot say Hyderabad is better than Delhi. There is no common scale on which you can compare them. Again, unless you change the definition, then you say we are comparing population of Delhi versus population of Hyderabad, in which case again you are considering population for comparison. You are falling back to continuous or frequency kind of data. Yeah, so at the core, nominal data is something where every information is distinct. There is no common scale to compare. Yeah, let's just quickly write a couple of examples for each of these data types so you can have a better idea over it. Height, salary, age, and so on. On frequency, you can say number of transactions. You say number of visits or number of girlfriends. Just kidding. Ordinal, you say feedback. or your t-shirt size, shoe size, t-shirt size, and so on. Yeah, or how much did you like a movie, and so on, ratings. And on finally on the nominal things, we have so things like, let's say, state, profession, and things like that. Let's say even your symptoms or the disease that you have, all kind of things which is distinct in nature, comes under nominal things. Yeah, so this is pretty much a formal picture of the types of data that you will deal on a usual basis. Yeah, this is the realms of machine learning precisely. When we talk about complex data things, we gradually shift to two specific subdomains, and they are NLP and deep learning. So these two specific domains actually deal with complex data. But when we talk about data analytics, machine learning, more or less the only possible types of data is on the screen. Okay. So again, a 1 minute pause. If you have any questions or anything, I'll check the chat window and wait for a minute. If not, then we'll move forward. So Shavik is asking, does frequency refer to discrete data? In a way, yes. Quite often, most of the literature or most of the books and articles refer to frequency also as discrete data. It's a common, alternative phrase for it. Not really. I mean, I'm not that kind of guy who goes into very, hard definitions of it. This level of segregation is reasonably fine for me. So, yeah, as far as my knowledge goes, there is no major difference. Nothing that you should be worried of. Okay, then in that case, we will move forward now. So now I'll try to answer one question. Most of you have some experience with programming, some inclination to IT. So this one 5 minute thing will actually help you acknowledge the difference between conventional programming versus machine learning. Okay. So before I acknowledge this, let's talk about a use case. uh, your mom asks you to buy bananas. He says, go to market, get some bananas. And now it's not a straightforward task, because your mom is kind of choosy. She says, do not pay anything more than 40 rupees per kg. And secondly, make sure that bananas are ripe enough to eat today or tomorrow. You should not carry raw bananas and come home. So now what is happening? There is certain kind of distinct, set of rules that govern your outcome. Yes. So in terms of programming, what do? You say, if the price is less than 40, then probably I will consider buying them. Again, that's not your final target. Then you will check if they are ripe. Yeah. And finally, if that is also true, then you say, okay, I'll buy it. In any other scenario, the end scenarios are going to be not buy. Yeah. So what just happened here? I made a flow diagram kind of thing. So you can actually make a program out of it, which basically takes input of the banana price and what is the banana state. Is it ripe or is it raw? And based on that, it will throw you an answer what you should do. Yes. So that is the conventional programming perspective that we usually have. What is happening? The input is data. In our scenario, basically the banana price and the banana state, along with certain set of rules or logic. Yeah, that logic was defined by your mother, and you coded it in some way and you made a program out of it. And finally, what comes out? Answers. Yes. So there is a hard way of things turning out, and this is your conventional programming. Yes. But what happens in machine learning is quite different. In machine learning, of course, you will require data for sure. But along with data, what goes in is not the rules and logics, but instead it is answers. And what eventually comes out is actually rules or logic. Yeah, so that's the primary difference between conventional programming versus machine learning, and that is why the machine learning phrase is quite apt. Based on the answers, it is actually trying to learn the rules. Yeah, it is kind of back propagating things. So that is a neat little difference to help you understand the difference between conventional programming versus machine learning. And a practical use case of this could be this. You come home with bananas, and your mother says, what the hell, this is wrong, you should not buy these bananas. Why? These are raw. So now you have a data which says that if I go home with raw bananas, my mother is not going to give me dinner. Now next time you come up with bananas, they are ripe, you're happy. No, mom seems happy. Then she says, what price did you pay for this? You say 70 rupees. She says, get out. No, neither will I give you dinner. You'll have to stay out for for the day. So based on these kind of feedbacks, basically you have your input data and the final outcome what it came. Now you go back, you do kind of think about the data, you come up with some logic. Finally you say, okay, you know what, if I go home with raw bananas, I'm not getting any food. If I go with expensive bananas, that's going to be a problem as well. Finally you figure out some logic. Yes. So machine learning relies heavily on answers, and based on that it tries to figure out logics that can help us in future. And now comes the perspective of supervised versus unsupervised. So this aspect is kind of optional. Yeah, the tasks or the approaches or algorithms which require this answer are supervised. So if answers are given, then it is supervised. Why? Because you have some logic to think about. Because of you have given answer, you can go back and redefine your logic or improve your logic. But on certain times, answers are not given. Yeah. When I ask out a girl, probably she says, shakal dekhiye. What happens? She basically rejects. She does not tell me, if my height was less or if my money was less. So that is something like unsupervised. So basically, you do not have any clear insight on what happened and why it happened. So there is no way of backtracking things and coming up with a smarter logic. So that's the very quirky way of defining supervised versus unsupervised learning. Yeah, so that's pretty much machine learning versus conventional programming. Again, a good time to take 1 minute pause. If you have any questions, I'll be taking answers from, or I mean questions from chat window. Okay, so Garima says, can you give an example that seems numerical and categorical but needs to be solved into categorical? Sure, I can do that. So the classic, problem used for this scenario is ratings. And let's say more on say feedback. So you are saying that excellent, uh, good, average, and bad. So now one way to look at this is these are separate distinct levels. So there is some aspect of categorical nature. But having said that, you know that excellent is always going to be better. So you can put a number on it. The way people put a number on it is, they say good means 1, excellent means 2, average means 0, bad means -1. Why? Because this aligns with our human intuition. Yeah, nobody can deny this scale of rating. So if I put this scale, it kind of becomes numeric in nature. But the major problem with that is it does not, confer to the rules of number line or any numeric data. And what is that? Let's say each increase in 1 unit from this, what is the growth? And each unit increase from here to here, what is the growth? This growth should be consistent. But the problem is I cannot measure this growth itself. So this is a classic ambiguity between should I consider it numerical or categorical? And then what you do is actually, the one thing that I forgot to mention. So when you talk about these segregations of data, uh, it's important to acknowledge these segregations. Why? Because all of the tools and techniques and approaches, logical approaches that you will use will differ for each of these data types. Yeah. So if I consider ratings as something numerical, one convenience that I have is I can plot them on one single scale. Basically, this becomes my rating scale. So now excellent is somewhere here, good is somewhere here, average is somewhere here, bad is somewhere here. Now it is not an accurate representation. Why? As I said, the rate of growth is not guaranteed. There is no evidence to justify that. But there is some kind of order. So it's not completely wrong either. Yeah, it's partially right, partially wrong. And alternative approach for this could be, you consider them as categorical. And the moment you consider them as categorical, there is no way you can plot them on one single scale. Yeah, this is absolutely not possible for categorical. So what you instead end up doing is you give separate axes to each of them. Yeah. So one of your axes is, let's say, excellent. You say if the person is excellent or the review is excellent, the data point is somewhere here. If not, it will be somewhere here at the origin with 0 value. The second axis becomes average, let's say. Same logic. If it is average somewhere here, if not somewhere at origin. Why? Because there is no common scale on which you can represent. Ambiguous information is not tolerated for data analytics. Yeah. So there are two approaches of doing this. Each of them has its pros and cons, and to be honest, there is no clear right answer. One estimate is conservative, one is very optimistic. Why I tell categorical is conservative? It leaves room for understanding the growth behavior for excellent versus average on a different scale. But the moment I put them on the same scale, I'm restricting the growth in a certain way. So I better be sure about the growth rate. So this is more optimistic way of doing it. You better know
then
what you are dealing with. And this is
this means
more of conservative. There is lot of room for ambiguity. I mean, factoring in ambiguity, dealing with ambiguity, or rather, better word would be uncertainty. Okay. So, one question by Nag is, will you elaborate on explanation between supervised and unsupervised things? So, when time is right, of course, we will talk in very much depth about this. Right now, I just wanted to give you an idea that if you are using data along with its answers, you are basically talking about supervised things. And if you are just providing data and trying to, make sense out of it, then it is unsupervised. For now, just live with this definition. When the time is right, when we'll talk about, different algorithms, different approaches, we will, talk about this in very depth. Right now, it's unnecessarily going to very specific complex things. A follow-up by Garima on the categorical versus numerical thing. She is asking, does this mean categorical data cannot be calculated? Not really. It is just a separate way of interpreting or no, representing data. One thing is you chose a way to represent your data. Second thing is you have certain algorithms and logical approaches to infer information out of it. Those are two separate things. So right now, when I decide it is numerical or categorical, I'm just defining the ground rules on which the information will be represented. How do I make sense out of it is a secondary thing. And when we will see different algorithms, we will see how different algorithm considers all of these data and makes sense out of it. So there's no question of it being calculated or not calculated. It's like just different ways of representation. Shavik says, speaking about numerical and categorical, numeric ratings can also be continuous when we try finding average rating, which may come in decimals. So that's a tricky one to answer, and actually, it's not accurate way of putting that up. When you say you are calculating an average, you are actually coming up with an average summary statistic, one number that will probably explain one subset of data, if not the whole data. Yeah. So that is not a way to represent data. It is a way to summarize data. There is two different things. Yeah. So right now we are specifically talking about representation of data. No summarization, no inferences, no predictions. Okay. So yeah, I think it is roughly 45 minutes. This might be a good time to take a 5-minute break. What I usually do is open timer on Google and we set a 5 minutes timer. Yeah. So you might take your biological break, water break, whatever you want. We will get back in 5 minutes. Okay, I am back. If I can have a quick confirmation everyone is back. Nice. Perfect. So now this another page is also going to be quite interesting. It will break a lot of your myths about machine learning. Yeah, but before that we can acknowledge that. Let's just put that question and see what your opinions are. So no, the simple question is, in your own words, short set of words, explain what is machine learning. Yeah, show me your perspective of what exactly you mean by machine learning, and I will wait for a minute and see for your answers in chat window. So I'm expecting answers from you regarding, what do you think machine learning is? So Garima says, method to train a machine to learn and adapt with different environments and situation continuously. Interesting. Shavik says, approach of machine to learn and suggest by observing some repetitive actions. Very interesting as well. Ruchika and Upanishad say machine is educated to solve our problems. Fair point. One answer by Nag is feeding data. Sorry, that came out wrong. Sorry, shit. Feeding data into machine to learn from data. Yes, learning from data is a good phrase. Yuvander says, learn and make learning patterns out of data. Yes. So more or less, you have the right intuition. Ishita says, feeding data to machine to learn from them and make it smart from it. Yes. It is interesting that half of you have used the words machine and learning in the same sentence, trying to summarize machine learning. What kind of definition is that? So you're supposed to break down into some layman terms and make it more intuitive to understand. I mean, I know you have the right intuition, it's just not the right way to represent your ideas. So the way I like to, again, this is my self-made definition, something which I feel is a good representation of what machine learning is. uh, I consider it basically a set of algorithms and logical approaches to do what? To help you generate value from data. Yeah, in a very small nutshell, this is what I would tell to any new person into the domain or any interviewer. Somebody says, no, what is machine learning? This one line kind of summarizes it. Now you can get more specific about what do you mean by saying that you generate value out of it. Yeah, what kind of value you are talking about, that can be elaborated further, but in one line this seems a fairly straightforward and sensible definition. So now we will talk about the types of value a machine learning machine learning as a domain can solve. Yeah, the one most popular thing uh, I'm sure you know is, yeah, so now basically I'm summarizing what kind of value you can generate out of it. The first and very popular, the most popular thing, having some kind of predictive power. And I believe most of you are thinking along the same lines. It is very synonymous to machine learning. When you say machine learning, you are all you're interested is about having some kind of predictive power, having to predict something. But now, step by step, I will unravel other aspects of machine learning as well. But before we actually talk about other things, let's just talk about a few use cases, in a quick manner. When you say predictive power, you can predict stock prices. Then you can predict demand for upcoming products, demand forecasting. You can predict whether this person will default the loan or not. Yeah, and so on. Anything that you're trying to have some forecasting power, some predictive power, comes under this section. Now comes the second section, which is kind of very generic, very common, but people often do not give the due importance it deserves, and that is Understanding the dynamics of system. What do I mean by this? Imagine you are working in a sales domain. So for you, it is very important to see where all of your leads are coming from. What are your site visitors' background? What is their behavior? What kind of visitors are making more purchases? What kind of behavior is actually leading to better sales and better conversion rates? Yes. So just to understand all of these things, you would probably use this machine learning domain to make sense out of it. Yeah. In uh, hard terms, it's like having an overview of the system. This is synonymous to dashboards that are very popular in ERPs and other systems, CRMs and everything. You have a dashboard that gives you a brief overview of what is going on, how many leads were generated in last months, how many conversions happened, what is the total revenue generated, and all kind of things. Yes, you are just trying to understand the dynamics. Why is it important? Because it assists better decision making. Decisions can be made on two line of thoughts. One is gut feeling, what you feel, what you perceive, and second, based on some data, yeah, some information, some facts. So when you have facts at your disposal, it is very important that you see them in the right perspective to actually make better decisions. Yeah. So this point two can be termed under traditional BI kind of thing, business intelligence, dashboardings, and those kind of things. Yeah. Might not be directly called machine learning, but it certainly is a part of machine learning domain. Yeah. You cannot disprove that. Then comes the third part, uh, extracting information from complex data. Yeah. So the moment I'm talking about complex data, you are inherently talking about dealing with textual data. You want to see whatever Twitter opinions are posted about our honorable Prime Minister Modi. No, are they positive or negative? Yeah. So you are using text to figure out people's sentiment. Yeah, there is no kind of prediction going on here. You are just trying to extract information, trying to understand what's going on. Another example of text extraction can be you have long very big corpus of knowledge, let's say Wikipedia articles. Now you want to make an intelligent system that can answer any factual questions. Basically, who is the Prime Minister of India? Who is President of US? What is capital of India? Yeah, these are factual questions which have only one correct answer, no ambiguity possible. But the point is, how can you teach a machine to do that? You basically take a large corpus, large knowledge base, I mean no large data, convert that into knowledge base. Yes. So basically, you take a very large piece of information, extract the right pieces of information, and organize it in a way such that it can help you answer questions. Yeah. So from a very large chunk, you are extracting the right set of things and also organizing them in a way which makes your task easier. Then you can talk about images. Doctors are trained to see CT scan images, chest X-rays, and basically tell if you have pneumonia, if you have tumorous growth or anything. Again, no prediction. It's just looking at images, trying to say what's going on. Yeah. So check for tumor, retinopathy, and so on. All of this, basically there is some complex information stored in images. You are trying to extract the right stuff out of it. And finally, you can talk about videos as well. Hyderabad police sometimes back implemented a video surveillance tool which could detect security breaches, check if the rider has is wearing the helmet or not. One gentleman made a a simple video analysis tool that could tell if a person is wearing a mask or not. Certain countries are using these kind of techniques to safeguard their ATMs. Yeah, ATMs usually have a front facing camera that captures who is dealing with the ATM. And if you come up covering your mask, that is like something shady is going on. So the ATM just wouldn't dispense any money if you come with a mask. So you have to reveal your identity to do a genuine transaction on it. Yeah. So at a broader level, again, these are the three types of things machine learning domain deals with. First thing is predictive power. Second is more dealing with visualizations and better conveyance of information. Yeah, telling conveying information in form of stories, in form of visuals. And the third is extracting information from complex data. Everything can be at a broader level considered under machine learning. Okay, so again, good time to take a 1 minute break. I will check for questions in chat window if you have any. Okay, then it's time to move forward. I hope everyone. Okay, Garima has a question. Are jobs like ETL and visualization fall under ML category even if not done by any data science concept? Um, okay, so here comes a disclaimer. Uh, this is kind of overlapping scenario, and technically, if I'm not using any algorithm or any logical approach, then it is not appropriate to categorize as a machine learning approach. So I see where your line of thought is coming from, and yeah, uh, basically you cannot call that machine learning for sure. But let's say you are taking in data, you are using some kind of summarization techniques. Let's say customers belonging to certain regions or customer belonging to certain subgroups. You do some kind of data manipulation on top of it for better representations. That is fine. Certain times you have no scope of adding multiple dimensions to your visualizations, so you fall back to techniques like the PCA and those kind of things to end up having a more sensible representation of data. So it's very difficult to say if it's not machine learning or not machine learning. And this is one of the rare classes where I kind of focus on the definitions or these kind of things, and more or less I have a strategy of problems versus solutions approach. There is a problem at hand, there are certain tools and techniques which will help you solve the problem. End of the story. I find putting hard words to definitions a redundant task, to be honest. Okay, having said that, now we have acknowledged what are the types of data, what are the ways to represent the data, then what is the difference between machine learning and conventional programming, and what are the tasks that can be handled by machine learning. Now we talk about much more realistic scenario. We basically say when you get data, what is going to be your approach? Yeah, basically what is your approach towards data the moment you see that data. So again, based on the tasks, your actions will vary. But before that, the thing that I like to point out is you are basically trying to understand nature of data. Yeah. Imagine this: your environmental setup has a coin. Yeah, and that coin has heads or tails. Now you want to understand the nature of this coin, and before you can understand the nature of coin, let's acknowledge what governs the behavior of this coin. That is much more uh, intriguing way to understand stuff. You're basically saying I want to understand the behavior of this coin. Yeah, so now let's acknowledge how, on what factors is the behavior dependent on. The one thing is inherent nature of the coin, and the second thing is there can be some kind of external circumstances. Yeah, when you toss a coin, the inherent nature of coin will govern the behavior, but at the same time external circumstances like the wind might also have some kind of impact on it. Yeah, it might or might not, but there is certain possibility. And the final thing that it can impact is randomness, or some people like to call luck. Yeah, so behavior of any object or anything is usually governed or can be summarized in these three approaches: inherent nature, external circumstances, randomness. Now when you say that you want to understand the dynamics of the system at hand, or you want some kind of predictive power, you are basically trying to find patterns in all of them. Yes, so pattern detection amongst all of these is your primary task. That is what you mean when you say you want to understand the nature of data. Now what is the approach to understand the nature of data? How can you understand the nature of data? One approach is, what, I don't think this is one approach is you have made the system by yourself. A real coin toss can have all of these problems, I mean all of these factors impacting it. But let's say you make a digital program, yeah, basically a random number generator, and it keeps on generating different numbers between 0 to 1. If the number is less than zero point 0.5, it is heads. If the number is greater than zero point 0.5, it is tails. So you have made a virtual system by some forms of rules and logics. Yes. So basically manually defined environment with certain set of rules that govern the behavior. The moment this happens, you know there can be no possibility of randomness, I mean lesser possibility of randomness. You can technically map out each possibilities of things. Why? Because you have defined the environment, you have set up every aspect of it. But what really happens is most of the times you do not have any control over the environment. Yeah, I cannot have control on an environment when I ask out a girl and she rejects me. Like no control. That's how just things are. So most of the things behave in their own way. And to deal with that kind of things, the simplest approach or the most sensible approach is empirical analysis. I'll try to say something witty. If the girl, seems interested in, she agrees to go out, that is, some statistical evidence for me to understand how to talk to girls or how to impress them. Yeah. So I am actually doing some kind of experimentations to figure out the nature of environment. Yeah. I'm trying to figure out talking to girls, and there are certain kind of empirical analysis. So machine learning pretty much follows, this approach. You are basically trying to understand the nature of system using some kind of empirical analysis. Yeah, but a major part of this empirical analysis is randomness. And I'll tell a small example will help you understand how critical that is. Let's talk about Virat Kohli. Yeah, what is inherent nature of Virat Kohli? Basically run scoring machine. Yeah, no matter what kind of bowler he is, he stands strong, he delivers. Yeah, he will kick people out of the park. The point is, let's say Virat Kohli's average run scoring is 70 runs. So when you say average is 70, what is it that you are trying to say? So on an average, you can expect this guy to hit 70 runs. Yes. So you are ensured if Virat Kohli is in my team roster, 70 runs to आएगी. But there is still an element of randomness, an element of luck. In spite of him consistently performing good, you cannot rule out the possibility of him getting out on a duck. Yes. So the moment you acknowledge this, you are actually opening up your environment for exposure to randomness, exposure to luck aspect. Yeah, that's what happened to World Cup semifinals. You cannot ensure that he'll play every time. So there is certain kind of randomness also that impacts the behavior of your data. And a big challenge is to filter out what happened because of randomness and what was the inherent nature of the data. Your aim as a data scientist should be to figure out these things, because there is certain pattern between inherent nature of this thing and external circumstances. There is some pattern that is governing behavior. But when you talk about randomness, there is absolutely no pattern in that. There is no standard thing that governs it. So randomness or luck is a very big factor which kind of challenges your analysis, and that is the reason things are not pretty straightforward. Let's okay, I think I'll take 1 minute break and check if you have any questions. Okay, so Garima is interested in knowing about multi-dimensions or elaborate multi-dimension of data. I actually can do that, but I don't think this is a good time to do that. If you can hold on this question, probably in the let me check. Mm, it will take a couple of classes before we reach a point where we can have a sensible conversation on this. Right now, it will be just something which does not fit our approach right now. Yeah. So when the time is right, I'll make sure I talk about that. Okay. Anything? else I'll just wait for 30 more seconds and then move to the towards the last topic of day. Okay, then that brings us to the last topic of day. Basically, challenges with empirical analysis. Yeah, as I said in the earlier slide, if is the behavior, or nature, the behavior that you're observing, is it its nature or just some randomness? Yeah. So figuring that out is very tricky. You have to figure out if there something is real information or it just happened because of some chance. Second thing, whatever I observed, whatever observed, is it sufficient to come to a conclusion? Yeah. Let's say I invite over my girlfriend for a match, and we watch the match, and I sell Virendra Sehwag very hard to her, like Virendra Sehwag is best, like kicks people out of the park. Now I have hyped her about Virendra Sehwag so much that she's expecting this guy to thrash every bowler coming into his way. And the next thing I know is, like, within two balls, Virendra Sehwag gets out for a duck. Yeah. So now is my girlfriend qualified, or does she have sufficient data to come to a conclusion? She might say, you just try to sell this guy hard, but this guy does not perform. So now there is a aspect of sufficient data, or sufficient informal words, sufficient statistical evidence to justify your fact. Yeah. So that is the second aspect, and this is the aspect where statistics comes in very, very, very handy. Yeah. So when you see certain observations, you might come to a conclusion, but is that conclusion backed by sufficient amount of data, sufficient amount of facts? That is a question that statistics will help you answer. Yeah. Let me give you an example to highlight its importance. Same coin toss example. So now, tell me, no, the coin has two faces, heads and tails. Both of them have equal weight. No, center of gravity is same. There is no wind impact. Everything is controlled in the environment. Yeah. Now, what is the nature of data? The object. Its nature is to land heads and tails equally, equal number of times. Yes. So let's say I toss the coin for 4 times. What are the chances that number of heads and number of tails are equal? I would want your answer. I'll pause for 30 seconds, and I would want an answer. Basically, the question is, if I toss a coin 4 times, what are the chances that number of heads is equal to number of tails? Yeah, simple experiment. You are saying the coin is unbiased. Okay, I am controlling the environment. I am saying unbiased coin, no external impact, no wind force, nothing. Okay, and in this kind of controlled environment, I am tossing the coin 4 times. Now tell me, what are the chances of number of heads? Very nice. So I see a lot of correct answers. In fact, everyone is correct. You say 50%. Yeah. So 50% of the times it actually aligns with our domain intuition. Basically, it follows the nature. But what happens for the rest 50% of times? It just does not confer to our rules of nature, or of the nature of the coin. Yeah. And in case if you are wondering how 50% came in, let me explain it very quickly. So the possible outcomes are head head, head tail, tail head, tail tail. Yeah. So through theoretical probability, you can say that all of them have equal chances of occurring. So this can happen 1 in 4 times, this can happen 1 in 4 times, this can happen 1 in 4 times, and so on. That's why one sample output can be this. Now if you see amongst them, only these two scenarios have equal number of heads and tails. Basically these are the scenarios where you can say that coin is unbiased. Had you seen this scenario, you might come to a conclusion that it is biased. And my question is this conclusion correct? Certainly not. Why? Because I have just tossed the coin 4 times. You never know what are the possible things when you toss it 10,000 times, let's say. Oh, I just realized that although I said 4 times, I'm considering binary outcomes. But anyways, let's answer the question first. Is the coin tosses enough to justify to coming to a conclusion? Certainly not. We require sufficient data. Basically data sufficiency is the first aspect. Second thing is statistical evidence. Yeah. So statistics will help you answer all of these questions, and at the same time the knowledge of probability will help us evolve our thought process and understand the nature of the system at hand. So basically the summarizing this whole class, what I wanted to give you was you must have seen this in movies. When you're going on certain mission, you first acknowledge who your opponents are, and that we did it in the first orientation class. Basically we saw that what are the kind of tasks that we need to achieve. Then second comes the environment in which you are going to work. Let's say you are supposed to go to Istanbul. You actually learn about Istanbul, what's going on there, what are the types of things that will you can expect there. That is what we did today. And finally towards the end, using this I explained you the intuition of no, what is your approach going to be when you see data. And this opens up prospect of statistics, which will help you make decisions or make inferences about the environment with much more certainty, much more sensible logical approach. Yes. So although I had planned the first class to be on linear regression, what I thought was that this perspective was much more important than linear regression. So that is the reason this has been delivered. The next class will talk about linear regression. We will take this forward and try to put some like algorithm which gives us predictive power. And once these two classes are done, I'm sure you will realize why statistics and probability are an integral part of data analytics. And then from then onwards begins the next 10 classes, or roughly that many classes of what I other people like to call as grueling, excruciating topics of statistics. Yeah. So but trust me, if you passed glaze passed through these 10 days of statistics, the like, next coming 10 days of statistics, then pretty much everything is very much sunny and more happening, more interesting for you. But in order to conquer machine learning, the correct foundations are actually established by right knowledge of probability and statistics. So I just wanted to set up the expectations and what kind of things will come forward and what is the importance of learning them. Yeah, so I hope now you can acknowledge the importance of statistics. Okay, so Ruchika and Upnisha say, example you gave showing two outcomes, it should be only one right for each toss. One right for each toss. I'm not sure what you mean. One right for each toss. One right
Yeah.
for each toss.
So I think rightly you said that
No. So let's now that we are trying to acknowledge it, let's just see what could have happened. Um, Actually, I had actually thought of doing it two times, and then whatever answer and whatever I said would have made sense. Now that I'm saying four times, no, the answer simply changes. Basically, first coin toss, second coin toss, third coin toss, fourth coin toss. What is the probability of head here? 0. 0.5, 0. 0.5, 0. 0.5, 0. 0.5. Another way to look at it empirically, what are the possible ways? So you say, head, tail, head, tail, head, tail, and head, tail. Basically, 2 power 4 possible outcomes. Now, for all of these outcomes, you calculate the number of heads and number of tails, and then you would come up to a conclusion saying that there is X% chance of them being biased or unbiased. So having said that, this is a little jumping from our chronology. Once I start explaining the probability stuff, this might get easier and more sensible. Right now, just assume this change two times coin toss, and then the 50% answer that you all guys gave was correct. If you toss it four times, the dynamics change a little. Even I'll have to check back what what would be the final number. To be honest, even I don't know. Yeah, but we will make sure we acknowledge these kind of scenarios when we talk about probability and statistics. So Shavik says sometimes we have overwhelming amount of data we choose to analyze sample size. Certainly. So what you're talking about is sampling, and the reason that you mentioned is not the only reason we do sampling. There are other aspects to it as well, and I'll make sure we cover that up. So when statistics starts happening, we will certainly talk along these lines. Okay, so that is pretty much it for today's class. Again, it was fairly simple and at a very abstract level, and it was there for a reason. Gradually, the complexity and the amount of facts and mathematical things that you learn will start on increasing. Yeah, so on the first day, do not feel intimidated. In fact, do not feel that this is way too simple for me. 2-3 दिन में गाड़ी इतना स्पीड पे चला जाएगा, then you really find it challenging. So today was more about acknowledging the system. Okay, then that would be end of today's session if you don't have any questions. Okay, next class I can keep it tomorrow or day after. I am fine with both of the options. We will okay, this reminds me of Discord. Let me open up Discord first. I'll just walk you through what's going on. So imagine when you are learning, communication is very essential. Now, if you want to ask a doubt, WhatsApp is not a right place. What happens? WhatsApp, certain times I pass some important information, some tasks or something. And then the next thing I realize is 50 messages I have followed after that message. and the critical piece of information is lost between some casual conversations, between certain doubts and these kind of things. So there is no easy way to keep track of all these things, and that is the reason Discord is very good solution to it. So here you have multiple channels. So welcome and rules. So basically this is a channel where I will be posting information. This is exclusively write access to me only. You can only see from this channel, you cannot write to this channel. On the other side you have separate channels to talk about separate things. For example, if it's a general conversation, you better use it here. If it is something regarding homework doubts, you better use this channel. If you are planning some future sessions on certain topics, that can be done here. So each perspective, each task, each type of problem has a separate channel to communicate. This will help us make efficient communications. So highly recommended, use Discords. In fact, I'll forcefully remove the WhatsApp group itself, so you are forced to use the right thing in the right way. Yeah, so make sure you join this Discord thing. If you have any issues, you can reach out me on WhatsApp or anything, and we will figure it out what's wrong. But Discord will be a very great way to communicate and keep things in place. And of course, WhatsApp, you have a lot of redundant pieces of information that sometimes you choose to ignore stuff. So Discord will have just quality information, nothing else. Okay. I will shift my headset in case if you want to have any conversation. You know what? I think that's pretty much enough. I don't think you have any questions. I'll close this session in that case if you are done.